Assalamu alaikum. This is example 5.7, frequencies and modes of an automobile. This is the statement and this is the important data. And here the important thing is that it states the radius of gyration R is 0.9 meter. So I have searched through the internet and got the help about this, because here it says the center of mass, center of gravity, CG, center of gravity is at you can say L1 means 1 meter from the front shocks and 1.5 meter from the back shocks or back linear spring. So but the radius of gyration is actually, we are familiar that it is actually the distance which actually locates the concentration of mass for rotation. So here when you type on internet how to create a regular rectangular body, actually what is requirement that we want to map or create a rectangular body, which actually uh, covers this complete volume and using these dimensions. So if the center of gravity is at 1 meter from the front shocks, so that means we will be creating a regular rectangular body, means 1 meter from the front shocks and from the 1 meter from the from this center of gravity, from this centroid, 1 meter from this centroid toward the back side before these back shocks, and 0.5 meter distance will be left out between the back shocks, between the uh, back shocks. So what we will be doing, that we will be creating two rectangular volumes like I have created here. You can see it here. If you sorry here, if you see it with shaded exterior, that on the xy plane I have created a simple sketch having these dimensions. You can check it out, that height is it's horizontal dimension, means this rectangle you will be creating a rectangle having length 2 meter, horizontal dimension 2 meter, and its vertical means this is the width. So here you can observe that how the dimensions are actually selected. So here artificial intelligence overview states to create a uniform rectangular body with a radius of gyration k 0.9 meter and center of mass 1 meter from either face, means from every face, this face and this face, perpendicular faces. From the perpendicular faces. So you must design it with a total length of 2 meter. So I have created it this 2 meter. This is the horizontal dimension, or this is the length. So I have created a rectangular volume of 2 meter, and now the important thing is to satisfy this radius of gyration, what will be the width? So here it states that specify total length of meter, and that the axis and a specific cross sectional with width, cross sectional width depending upon the chosen rotational axis. Here, so to determine the total length. Total length is 1 meter, because 1 meter from on the either directions of the centroid or center of gravity, means 1 meter from here and 1 meter from here, some here. So after that it says that choose the rotational axis. So the remaining dimension width depends upon which central axis is the body rotates around, which the to achieve the k is equal to 0.9 or k square. So option A, rotation about the axis perpendicular to the length and width. So here you can say this is actually the total length between the, you can say, shocks, and width is actually this vertical dimension. The width is this vertical dimension. The perpendicular dimension actually does not affect, because actually we are actually only performing planar analysis, planar. So this is the rotation axis, the pitch axis you can say, or the rotational axis is actually perpendicular, passing through this center of gravity or centroid. The axis is perpendicular, so the central axis is actually perpendicular. So here this is the case, rotation about the axis perpendicular to the length and width. This is the length and this is the width. Vertical is the width, vertical is the width. So this axis is perpendicular to length and width. So the formula here for the radius of gyration about a central perpendicular axis is, this formula is actually k square is equal to L square plus W square, means length square plus width square divided by 12. So this is the analytical formula which you can consult from some basic geometry books. So substitute the known values. It says that here the width comes out to be here 2.392. So you will have to actually input this value 2.392. So this is the width. So you will be creating a rectangle in the xy plane. This side of the rectangle might be coincident with this vertical axis, so but it is not necessary. I have just made it coincident with the vertical axis just for facility for creation of the rectangular volume which is actually affecting. So you have created length and width, and after that you will be simply extruding it. So how you will be extruding it, you can observe it here, that you will be extruding it here both symmetric and extend type fixed, and depth will be 0.5. 0.5 means because the direction is both symmetric, so means 0.5 meter from this direction and 0.5 meter from this direction. So total width, total depth or total extrusion depth will be 1 meter. So that means actually the perpendicular dimension or the extrusion dimension, extruded dimension will not be affecting the total value of the volume. So volume will only be actually decided by the product of length and width. Width is vertical, so the perpendicular dimension, which is actually the extruded dimension or extrusion depth, will not be affecting the volume of this rectangular or body, which is highlighted in green color at this moment. At this moment it is highlighted in green color. So the volume, because this depth is 1 meter. So like this. So this extruded rectangular volume has been generated, which actually satisfies the radius of gyration. After that I have simply created, for example, I had simply selected this face. For example, I can make you understand here like this. Yes, for example, I am just, you can say, suppressing it here like this. I had simply selected this face, for example, like this, and one you will be selecting on this face, and after that you will be clicking on new sketch, or you don't need to click on new sketch. You can only click on sketching here like this, and you can start creating a sketch. And how the sketch will be created? So I had used it here. I can just for you can create a fresh rectangle coincident with the edges of this existing volume, or you can use here this in the draw menu, sorry, in the modify menu. In the modify menu you can use this duplicate. You can use this duplicate option. So duplicate option is like the project command which you had studied in crew parametric. Project command actually, as you had studied, that it actually projects the existing edges of the model which is lying in the background onto the current plane, like this. So what you can do, that you can click on replicate. I can duplicate like this. You will be selecting this edge, and after that you can press the control button from keyboard like this. Click on here, press control button. I have pressed the control button, and like this. And after that you will be right clicking, and here you will be clicking on duplicate selection. But I am not now clicking on selecting the duplicate selection, because I have already used this process. And after that, once this rectangle will be duplicated, after that you will be simply clicking on create and extrude, and you will be extruding in this direction, in you can say in the positive x direction, in this direction, not symmetric dimension, and the extrusion depth you will be giving 0.5 meter, because this 1 plus 1 2 meter rectangular volume has already been generated. This length 2 meter has already been generated to satisfy the center of gravity or the centroid. So only 0.5 meter depth is actually left. So you can create, you can say, the auxiliary volume. And remember, this auxiliary volume will actually be massless. It will have, you can say, zero weight. This volume will only be used to attach this rear shock or rear spring. Its purpose will be only to attach the rear spring. It has no other use, because only the mass, center of gravity, and the moment of inertia will only be satisfied with this rectangular volume of 2 meter multiplied by 2.396 extra, this width, length and width, this volume which has already been created. So I have told you, you can use the duplicate option for projecting, or you can freshly create. Simply you can say click on the rectangle command and you can click on here at this moment and here, like this you can create a simple rectangle at this face, so that will also be working. So like this. So uh, you can say uh, now I am actually unsuppressing it because I have, and after that you can say this point 1 you can also unsuppress it. So remember, these two volumes have been created. After that I have created these 2 points, and I have later found that creation of these 2 points 1 and 2 is unnecessary, because actually these 2 points have been created on the midpoint of this bottom edge of each face, this face and the face lying in the background here, and you can say this face in the middle point. So if you want to create that point, you can look at its properties that you will be creating on here, and click on point, and after that you will be selecting from the pull down menu point load, and after that it will be saying that select on base faces. For example, you can click on here on the edit selection, you can say here that you will be selecting first of all the point load, and after that what you will be doing, that you will be inputting here point 5. You will be selecting the guide edge. After the guide edge you will be selecting this edge, you will be selecting this edge, you will be bringing the cursor here and you will be selecting like this edge, and you will be clicking on apply like this, and after that you will be inputting in the FD1 sigma greater than 0 here 0.5, not here, because edge offset means offset from the edge, but you are actually locating on the edge, you are not offsetting from the edge. And after that face offset is also not required, only sigma greater than 0 you will be inputting half, because the total length of this edge was 1 meter, so 0.5 meter. So similarly you can create the second point, and I am clicking on generate here. So point 1 and point 2 creation is quite optional, otherwise you can skip it, that will not affect. So in this way two solids will be generated. After that you can import the model into the, you can say launch the model cell A4, and now you can click on the first model or solid geometry, and here you observe that its volume is 4.784. so this volume will be automatically obtained, and after that you are actually required to create a mass of 1000 kilogram. So what you will be doing, that you will be actually uh, observing it here some different mass depending upon the density. So what you will be doing, that you will be dividing 1000, the required mass, divided by this volume, and after that you will be you well know that you will be creating two material. One, for example, I have created as the car mass, and other is the frozen massless, means the other body that I had created, I had actually created it as the you can say frozen, because this was created as the add frozen property here. Sorry, you can say add frozen property. Why? Because I wanted to create two materials, because if I created add material, so this will become collectively single material, just like it was the whole body has been created in a single step. So its centroid and moment inertia will be changed. So I have actually created this auxiliary volume just for attachment of the spring. It has no role in the moment of inertia or the weight or its center of gravity or center of mass. It has no role. This volume, it has no role. So that is why I have created two materials here. One is car mass and other is the frozen mass. Frozen mass less, I have given it 1 e minus 40. You can use minus 20. That doesn't matter. Actually I was not actually getting the result after many trial, so I was actually unsure that might be the reason for the uh, this density. So I had used much smaller or much lower value for the density. So this is the car mass. So car mass density here will be calculated like this, that you will be dividing 1000 divided by this volume, so you will be obtaining this density 209.03 kilogram per meter cube. So then you will be refreshing materials and you will be obtaining this mass listed here as to be 1000 kilogram. And very important thing is here, that you will be observing it here, that one inertia must be listed here as to be 810, about, means about 810 kilogram meter square, like this, because the in the solution that has been calculated or used it here, because J is equal to mr square. So here this is the value, means J naught. So J naught value is actually 810. So this is actually the magnitude of the polar mass moment of inertia 810. So you must verify that it should be shown here. So A10 has been shown here. After that you can say the other volume is quite massless, as you can observe it here, minus 40 is, and regardless of its volume. And after that what you will be doing, that you will going into the connections, and in the connection you will be creating a fixed joint between this adjacent face, between the common face of this volume and this volume, this central face, this face which is the common face between this volume and this volume. So you will be hiding one body, for example this body, and selecting the face from this face from this volume, and after that you will be showing this body and hiding this body, and sorry, you will be uh, hiding this body and showing this body, and you can rotate it further, and you can select the other face from this volume, and you will be simply fixing those faces. And after that you will be creating two springs. Simply you can click on this face, and this is the, you can say, rear shock. So the value for the rear shock, as you observe it here, that it is actually 22 kilonewton per meter. This is this 22 kilonewton. So you can simply click on this face or the point that you had created, like this, or you can click on with this vertex, and here that point will be highlighted. So you might have selected at that point, that will not be actually affecting the result. So 20, and similarly you will be creating the second spring, and here you can specify the length of the spring. You can observe the mobile the coordinates of the mobile point, and depending upon the, you can say, the length of the spring that you will be assuming. For example, 1.5 meter in the negative direction, because the center is at 0 location. So for example, you can say the length of the spring is 1.5 meter, so this is below in the negative y direction. And similarly for the other spring as well, as you can observe it here, its length is also same and coordinates are same. And other I think you will be familiar with this technique of specifying the coordinates for the various springs, because you have attempted it many times, and at this stage you don't, or you shouldn't have any confusion. So after that, the important thing will be analysis setting. You will be setting it here two modes, and after that you will be inputting remote displacement. And in the remote displacement you will be selecting or you either you can control select these two faces in the foreground, or you can select any one face, for example this face, because these two bodies here are actually fixed with each other, so only you can select this face. So you will be selecting this face, and after that you will be noting the values for the coordinates, that y must be free. Why? Because in the bounce direction is the vertical direction, so y coordinate must be free, because the car body is actually moving vertically down linearly, so y coordinate must be free. And the other is the rotation must be free, so you will not be input x must be 0, x must be 0. This is very important thing, that x must be 0, because the x motion is actually not required. So y must be free, and the other is the rotation, because z axis is the polar axis, so rotation z must be, and behavior must be rigid. And remote displacement 2 is not required, because actually I was not getting the result, so I had made another trial, so I am simply deleting it. So only one remote displacement will be working. And after that you will be you can say inserting the total deformation, so it will be by default giving you first mode. But after that you will be, once you have actually obtained the both modes, after that you will be clicking on it here like create a mode shape result, and you will be listing it here total deformation 2 and total deformation 3, and you will be renaming it. This will be mode 1 and this will be mode 2, like this. Here you can observe its simulation like this, and from the z-axis here you can observe it like this, like this. So both modes will be simulated like this, and I hope you have understood, and I have shown you all the result and complete solution for this model. This model is very important and very beneficial for you, so you will be understanding it and attempting it up to your best efforts. And if you have still any confusion, you can fairly ask, and I will always be there for you to help. Thank you.